This video does talk about the pointer arithmetic. So earlier in the previous video, we see the relationship between array and the pointers. You can see the pointer can associate with the square bracket operator as the array. But also I want to show you is the pointer we can do some addition and subtraction to move the elements through the array as well. So we see here, this one is earlier we told you. If we have an array name called VALS, the vals, so we can using the square bracket to access elements start from 0 to size minus 1, 1 by 1. So we can assign the value. So if we have our another pointer define the val PTR equal to the vals, I also can using the square bracket to associate with our pointer variable like array name. So this one is using the square bracket operator. So they can either work with array name or the pointer refer to the beginning of the array. And also we can do some calculation using the indirect operator as well. So when we're using the indirect operator, before we see using the indirect operator to associate with array name, if we only do the asterisk vals, they will refer to the first element of the array. So actually, this vals array name can add 1, add 2, add 3. So when you add 1, add 2, add 3, they are kind of like your index. So this index is if you have your vals plus 1, they are working like the index square bracket 1. So here, if I do the array name plus 2, they work like you have your square bracket, but put the index equal to 2. So these two actually, they work the same. But one thing is, if you want to using the indirection operator, you need to have your array name or the pointer name do some addition or add 2. So then don't forget, you need to have this one put in the parentheses because this one is the memory address calculation finish. Then I do the dereference operator. So that's why they will be the same as the previous one. So this one is we call the one of our pointer arithmetic. So the pointer arithmetic, when we do the addition, right, before we talk about the pointer is holding the address. But when they're holding the address, when we do the plus 1, plus 2, they are not plus the byte. They plus 2 mean they plus 2 times the data type of the pointer. Then they do the calculation. So that's why I want to remind you to be careful. When the pointer variable try to add 1, actually they are not mean they just add 1 byte. They are add 1 times size of the data type. For example, if this pointer val PTR is the int data type, they were using the plus 2 mean plus 2 times the int data type is 4. So 2 times 4 become 8 to add to the address. But here they just simplify with that. Just like your array index. How array index, we can using the index to move forward the element 1 by 1. Because those index, they already calculate the data type size. So then they know how much they need to move forward. Like we see here. When we do index 1, you see we do 0 is 4. Then when you do 1, we do the next. That's because they know the data type here is int. So they just right away move the 1, actually they move 4 bytes each time. So if you are double array, each time the index move, they just move 8 bytes each time. So when the array, they already consider the data type when they calculate with the index. So that's why when we work with the pointer arithmetic. When we do the +2, +3, +4, they already consider this number you are trying to plus. They already multiply the size of the data type. So that's the pointer arithmetic. So to continue, actually your pointer arithmetic, not only you can +1, +2. For your pointer is equal to the array name. So then when you do the val ptr++, actually they just have going to the post increment. So you see we start from 4, right? So we plus. So then of course they would point afterward they point to 4. So if we do the minus again, so then 4 go back to 7 back to the 4. So then that's earlier we talked about. You can using the dereference, but you do the calculation first. So using the pointer +2, actually they already do the 1, 2. So they including the data type as the element. So that's why when you +2, they point to the 11. So now again, you see we got the pointer refer to the beginning of array again. So then they point to 4. So you see, you can also do the not only the post increment or just the arithmetic calculation. And also, did you remember this kind of operator mean the val ptr plus equal to 2? That means val's ptr equal to val's ptr plus 2. So those combined operator also work as well. And also even the pointer itself with the array name, they can do the calculation as well. So that's the pointer arithmetic. So why we can using those pointer calculation? So actually those pointer calculation help us to go over the array element one by one. You can either want to reverse or do the beginning to the end to display the content of the array. Or also you can reverse order to display the array content. So we see the example 6. So example 6, we create a set array. We have 1, 2, 3, 4. We have 8 elements in the size of set array. So this set array, I can using another pointer called non-ptr to refer to the array. So you see here, after I have my pointer refer to the beginning of array, right? Right, before we always using a for loop, using the index to display the array content. But now here, actually, we can all using our pointer to do that. So if I have my non-ptr refer to the beginning of the array, so then I can display the first one. So that will be 5. I'm using the dereference operator. So then you see afterward I can do what? So that's my for loop, right? So when the count equal to 0, count less than size, count plus plus. So now I don't use the count as index. I just every time I increment my pointer by 1. So that's why after the first iteration, I have the 5. So then I increment by 1. So then when we come back, I refer to 10. So I display 10. So I increment again, so I display 15. So continue 20, 25, 30, 35, and 40. So then I finish. So when I finish, actually I refer to where? Yeah, so actually my non-ptr, because after you display 40, you still also increment by 1, right? So afterward, they will display, the non-ptr actually point to the end of the array. So now, since I point to the end of the array, right? So now I display the array from the first for loop in line 18 to 22. I do the beginning to the end. So now how about I do again? But this time I will coming back. So I decrement. So here beginning I point to end of the array. So I need to decrement again. So I point to 40. So I display 40. So then I decrement again, I display 35. So 30, 25, 20, 15, 10, and 5. So then you will see afterward, the second for loop, because beginning of the pointer, they point to the end of the array. So I decrement one by one. They will display the content of array in the reverse order. So that's what you see. Of course, you should download example 6 and try to see how the result is, right? So we can see here we have our example, chapter 9, example 6. So then we have our array from 5 to 40. So we have our pointer called non-PTR to refer to the beginning of the set. So now you can see here we have the first for loop. We use the dereference and we increment our pointer one by one each time in each iteration. So they will display from 5 to 40 in the beginning to the end. So then afterward, your non-PTR refer to end of the 40. So then we decrement the pointer. So then in the second for loop, you will see the numbers in the set array will display backward. So then you run the program to see the output. Is that correct? So that's our pointer arithmetic.